Check whether I have 3 points A, B, and C with position vector which is given here are collinear or not. Okay, let us begin. Now here we begin by considering some origin O of a coordinate system such that the position vector, we can define now the position vector of point A will be given by OA vector. Let us suppose that this is defined by negative 2A vector plus 3B vector plus 5C vector. Then the position vector of point B, we're going to call it OB vector. Let's say OB vector is defined by A vector plus 2B vector plus 3C vector. And then position vector of point C, let's say that's OC vector equals to 7A vector minus C vector. Fine. Now, what we'll do, we'll try to find out the vector AB. Now, in terms of the position vector, point A, the vector AB is going to be defined by OB vector minus OA vector. All we've done is take the position vector of the endpoint, which is B, and from it subtract the position vector of the initial point, that is A. That will be equals to, so we have A vector plus 2B vector plus 3C vector. So this is the vector corresponding to OB. And from here, we're going to subtract OA vector. So that's negative 2A vector plus 3B vector plus 5C vector. So this is going to give us, so we have A added to 2A vector. So that's going to be 3A vector. 2B vector minus 3B vector is going to be negative B vector. 3C vector minus 5C vector is going to be negative 2C vector. So we're going to label this as number 1 and keep it aside for the time being. Now let's say we want to find out the position, the vector BC. So in terms of the position vector, it is going to be OC vector minus OB vector. Now what is OC vector? That's 7A vector minus C vector. And from here, we're going to subtract OB vector, which is A vector plus 2B vector plus 3C vector. Fine, that's going to give us, so 7A vector minus A vector is going to be 6A vector. Then we have negative 2B vector. Then we have negative C vector minus 3C vector means negative 4C vector. However, we can further simplify this. Now, if we take 2 as the common factor, so we have 2 multiplied to 3A vector minus B vector minus 2C vector. So that means we have BC vector. This implies that BC vector is equals to 2 times. So 3A minus B minus 2C, that's nothing but the vector AB. So we have 2 times the vector AB, which means that we have been successfully able to express the vector BC in terms of AB. All we have to do is multiply it with some scalar which has a value of 2. So this tells us that point A, B, and C, these 3 points are indeed collinear in nature. Only when they are collinear, we can express BC vector equals to 2 times AB vector.